if I'm going to draw two lines, okay, first of all, let's put some axes here. Okay, here's some axes just for reference. If I'm going to put two lines on here now, okay, put one red one. Okay, it doesn't matter where we're going, right there maybe. Maybe I'll try again. Let's go like this. No, let's not. Let's try again. That. Okay, there's my first line. If I'm going to do another line here, it can be anywhere, and there's a lot of different situations that can happen, but you can put it into three categories. If I'm going to draw another line here, you can put it into three categories. If I draw another line, the other line might intersect this line somewhere, and most of the time that's what's going to happen. If I draw another line here, it's going to intersect somewhere. Intersect means obviously to cross the thing. Okay, you could do it this way or whatever. All of those are intersecting, right? How many solutions would that situation have? How many solutions would that pair of lines have? One, right? They cross in one spot, right? So one of the things that you can have is you can have, if the lines are intersecting lines gives one solution. Okay, there's one point where they cross. That's situation number one. Situation number two here, what are the only other things that could happen? They could either intersect once, or is there a way they could not intersect? Do these intersect? This is a trick question. If they didn't have arrows on the end, they don't intersect. But what do the arrows on the end mean? They keep going. If these keep going, what's going to happen with this red one here? It's going to cross it eventually. So even though this doesn't look like intersecting, eventually it would intersect. Is there a way I could draw it so that it doesn't intersect? Absolutely, if it was parallel. How can I ensure that it's parallel? Is this, does that look like it's parallel there, you think? Does this look like it's parallel more? Closer? I can tell you whether those are parallel or not, not just because of the way they look. How can you tell they're parallel? This is something you've learned already in the last unit. The slopes, you can look at the slopes. What's the slope of this one by the looks of it here? 1/2, right? Everywhere you go, this goes 1, 2, or 2 over 1 up, 2 over 1 up. So the slope is 1/2. What's the slope of this one? It sort of looks like 1/2, but what starts to happen here eventually? Up here, what's happening? Is it, if it went perfectly 1/2, it would be that point, that point, that point. What is it? Is it sticking to that exactly? It's kind of going a bit off of that. The slope's not exactly 1/2. Those are almost parallel, but not quite. If you extended them forever, eventually these would cross down here. Eventually. If you want to make sure they're exactly parallel, what do you have to make sure about the slopes here? 1, 2, that point, that point, that point. It has to be exact. Those are exactly parallel as long as the snapping to the grid things work. So situation number 2, this was situation number 1. Situation number 2 is parallel lines. You have a place to write this on your study guide. How many solutions are there if the lines are parallel? No solutions, or 0 solutions. If you have two lines that are parallel, they don't ever cross, there's no solution. There's no intersection point. Make sense? I hope that makes sense, right? Parallel lines don't cross. That's the definition of parallel lines. They don't cross. So if you have two lines that don't cross, there's no intersection point, right? The intersection point is the solution. There is one other situation. Either they cross once, they don't cross at all. Can they cross? Well, I guess the question is, here they don't cross at all, or they cross once. Can they cross more than once? Can I make two straight lines cross more than once? If you take two straight things here, okay, I'm not showing this on the screen, but if I took this meter stick and I took this meter stick and I held them up, I can make them so they cross once. I can make them so they don't cross at all if they're exactly parallel. Can I make them so they cross more than once? What would I have to do? I'd have to bend one of them, right? And they don't bend very well. If we're saying the lines are straight, you can't make them cross more than once. The only other situation is kind of a goofy one, but what's the only other situation? Right, if they were right on top of each other, if they were the same line, if they're right on top of each other, how many times do they intersect? An infinite number of times, right? So this is kind of a weird thing here, but if you have two lines that are exactly the same line on top of each other, so if I drew this one so it's exactly the same line there, do you want to see that again, a replay of that? Here's a slow motion instant replay of this. If this line turns out to be the same line here, okay, start there, this line is right there. It's the same line, there's two of them together. What do you think the word for that is? What do you say if things happen together? Two things happen together? What a coincidence. Coincident. Coincident. Incident means something happening. Co means together. Two things happening together. Coincident lines. That's a word you should learn. Coincident lines. How many solutions? Infinite. If you really like that infinity symbol, it's like that sideways H. Or you could write the word. It's totally up to you. You could say infinite number of solutions. Okay, infinite number of solutions. Coincident lines. So there's the three situations. On your study guide page, there's a place to draw some nice pictures. See how those words are there for you? What you need to do is either come up with your own equations. This would be nice. This would be a good higher level thinking thing to do. Draw your own example for each. And then write the equation for each of your examples. Okay? There's the three situations, right? Intersecting lines. There's parallel lines. There's coincident lines. You need to write something for each one here. Okay? Coincident lines is pretty easy. I tried to put some things here to help you talk about what's true in each case here. What's true about the slopes? What's true about the y-intercepts? Are they the same, different, or doesn't matter? And the number of solutions. We already talked about how many solutions, so you should know that. This activity should take you 10 minutes or less. Unless you're just staring with this page open on your desk talking to someone, then it's probably going to take you an hour. Right? We do not have an hour to devote to this activity. We have 10 minutes at the most. Once you're done with that, there's some examples in here. These are the examples that are in the textbook. The goal here is to do this without graphing. I know that you could graph it and look, oh, they're intersecting, or oh, they're parallel, or oh, they're whatever. The idea is that you have to use your head and say, can I tell from the equations whether they're going to be intersecting, coincident, or parallel, and how many solutions? That's why it says here predict. Okay, predict the number of solutions without graphing. Look at this and decide, wait a sec, the slopes are, the y-intercepts are. So you got to use the information you came up with in this table to make decisions there. That's what it means, explain your reasoning. Your reasoning is going to say stuff like same slope, same y-intercept, or same slope, different y-intercept, or different slopes, or whatever, something like that. Once you do that, do you notice that there's a your turn and then there's some questions here? You can feel free to omit a few of these if you're running low on time, but you've still been working away at it. Once you think you nail down the concept, because it's more important for us to spend some time today getting started on this, starting the representing real situations. You have 40 minutes right now, just over 40 minutes till we have lunch. In your 40 minutes, I would say devote 20 minutes to that section 4. And then, or 20 to 25 minutes. And then spend 15 to 20 minutes getting going on section 5. Okay? That's going to be important that we do. It really is important that this week we nail down a good chunk of this this section, okay, or this chapter. We want to leave finishing section 5 and getting section 6 done for next time. We don't want to have to do both and not even have touched it. Can you get going on things, please? Hey, around your group, if you have questions, feel free to ask the other people at your table. Even if you don't know them, you can introduce yourself. Don't poke other people at other tables or anything like that. Just leave them alone. If you find that you can't keep your hands off somebody at another table or somebody at your own table, there is the isolation booth over here, okay? Or the table over here of people who need to sit at a table by themselves. Or there's 5 stations at the side that you can sit at. You know that, right? They're flat screens, but they're not very exciting flat screens. If you haven't got if you haven't started to feel like, hey, I actually better get going on something here by this point, I don't know. I'm losing hope for you, right? This is getting down to like the New Jersey Devils, and it's game 3 for them, it's starting to be a game like they're running out of chances at this point, right? You only got a couple weeks left until your exam. You have to finish learning this chapter and review everything. Don't leave learning this chapter till the last minute. Do something right now. And the first step is me being quiet so you can get going.